Hello everyone, welcome back to Matrix lecture series. In the last lecture, we started with the new exercise, exercise 3.3, and we discussed till question number 4. Now we are going to begin the discussion with question number 5. In question number 5, I have given two matrices A and B. This is my A matrix, this is my B matrix, and I have to verify this. What this basically is? This is basically the property that we discuss. Okay, so in this question we have to verify this, that whether this holds or not. Let's see this. There are two parts, part A and part B. I am doing this part, you can yourself try this B part. It is in exactly similar lines. Okay, now let's see. Okay, I have question number 5, part A. My A matrix is this, my B matrix is this, and I have to verify this thing. Okay, so basically if you focus this part, if you focus LHS, I have to first find AB and then find to transpose. You very well know how we multiply the matrices, right? We can simply multiply the A and B by multiplying this row with this column, this row this column, and similarly other rows and other columns. Okay, now we will then find the transpose. You also know how we find the transpose. Just change the row to columns. In this way we get A B inverse this matrices. Okay, now move to right hand side. This is my right hand side, this is my right hand side. Okay, in the right hand side, what I have to find first? I have to first find, as you can see, let me change the color. As you can see, we have to first find this B transpose, then A transpose, and then we have to combine them, basically multiply them. So first I have find it A transpose. How you will find? Simply convert the row into column. This is how you will find A transpose. This is how you will find B transpose. Now let's multiply them. Let's multiply both of them. Let's multiply B transpose with A transpose. Okay, remember B transpose is at first position, so the resultant matrix will be of order 3 by 3. If you do not know how I have claimed this, then you should watch the previous video in which I have explained you the multiplication of the matrices. Okay, now moving ahead, if I multiply, then what will I get? Let's see. I get here -1, here -4, here it should be, okay, here it will be +4, and here it will be -3. Okay, 2 minus 8, 6, then 1 minus 4, 3, 1 minus 4, 3. Let me erase this now and show you that whether they are same or not. Let us check it. This is RHS. Okay, this is LHS and this is RHS. If you examine that, then both of them are exactly same. Hence what we can say, that LHS, we can conclude that LHS is equals to RHS. Hence it is verified. Hence it is verified. In this way you will approach this question, right? Okay, the second part is exactly on the similar lines. You can do by yourself. Question number 6. In question number 6 we have to verify this thing. Now this is a sort of important question. Important in the sense that it involves some trigonometric functions. That's it. Otherwise it is also very simple. Just the normal transposition, then multiplication, and then we have to just verify that it is equals to be an identity matrix. Let's solve question number 6 part A. Okay, question number 6 part A. What we are given? We are given with the matrix A. A matrix is cos alpha minus sin alpha, sin alpha, cos alpha. Okay, I have to first find A transpose in accordance with this, right? In accordance with this, I have to find A transpose, then I have to multiply it with A. If I transpose it, what will I get? I get cos alpha, sin alpha minus sin alpha and cos alpha, right? Now multiply A transpose with A. What we will get? We will multiply this row with this column, right? So when I multiply, I get cos square plus sin square, cos square alpha plus sin square alpha, which is 1, right? Now if I multiply this row with this column, I get cos alpha into sin alpha minus sin alpha cos alpha, which is 0. Why? See, I get sin alpha cos alpha minus sin alpha cos alpha, right? And this is 0. This is 0. Similarly, I have to multiply this row with this column. What I will get? Sin alpha cos alpha minus sin alpha cos alpha, which is again 0. Then next multiply this row with this column. I get sin square alpha plus cos square alpha, which is 1, right? And this is equals to identity. This is what we want to verify, right? It is verified. As you can see, it is a very simple question, just the normal concept of first transposing and then finding the matrix multiplication. That is it. With this we are done with this 6th question. Also you can try part 2nd. This is exactly on the similar lines. Now let's move ahead to question number 7. In question number 7, we have to show that the matrix A is a symmetric matrix. Okay, and in part B we have to show that this matrix is a skew symmetric matrix. Now if we apply our trick, then we can well know in advance that this is going to be a symmetric matrix. But here we have to show it. How we will show it? We know that while showing the symmetric matrix, we are supposed to show that A transpose is equals to A, right? So first quickly find the A transpose. Okay, let's quickly find the A transpose. Question number 7, part A. Our A matrix is 1 minus 1 5 minus 1 2 1 5 1 3. If I transpose it, what I will get? I will get 1 minus 1 5, 1 minus 1 5, minus 1 2 1, minus 1 2 1, 5 1 3, 5 1 3. Are they both same? Yes, you can see that A is equals to A transpose. Hence it is proved. Okay, it is proved that it is symmetric. Also you can verify that it is symmetric in your mind using the trick. What was the trick? I am again explaining that the corresponding elements, these should be the same. As you can see, I am again highlighting. The minus 1 is same as minus 1. Here 5 is same as this 5. This 1 is same as this one. Regardless what is there on the main diagonal, the opposite should be same. Then it will be symmetric matrix. Hence, beside this, in your examination, you are supposed to do in this way. You are supposed to show that A is equals to A transpose, right? It is also done. Similarly, you can do this part also. We have to show here that they are skew symmetric. How we will show? We will show this by proving that A is equals to negative of A transpose, or you can prove that negative of A is equals to A transpose, one and the same thing. You can very easily prove this part also. And with the help of trick, you can see that the elements on the main diagonal, let me highlight for you, the elements on the main diagonal are all 0. Hence, we know that it will definitely be a skew symmetric matrix. But in the examination, you are supposed to show that A is equals to negative of A transpose, right? Okay. Question number 8. In question number 8, we are given with the matrix. We have to verify that this is symmetric matrix and this is skew symmetric matrix. Basically, what is this? This is basically a verification of theorem number 1. We have seen theorem number 1. It says that if A is some square matrix, then such A plus A transpose will be a symmetric, and A minus A transpose will be skew symmetric. This is just a verification of the same theorem. Let's see, let's verify it. Such questions of verification are quite simple in nature because we already know what the end result is going to be, and in accordance with that we can try to think that how we can approach it or how we can reach that point. Okay, so in question number 8 we are given that A is 1 5 6 7. This is the matrix given to us. In the first part I have to show that A plus A transpose is symmetric. I will show how I shows any matrix as symmetric matrix. If B is my matrix, then it will be symmetric if it is equals to B transpose, right? The same approach we will use here. Let's first find A plus A transpose. Okay, what is A transpose? First of all, it is 1 5 6 7. Okay, so A plus A transpose will be 1 and 1 2, 6 5 11, 6 5 11, 7 to 14. This is A plus A transpose. Okay, now if you find A plus A transpose whole transpose, what it will be? See, 2 11, this is one row, this becomes a column, and this is second row, this becomes second column. Are they both same? Check. Are they both same? Yes, they are exactly same. Hence what we can say? We can say that A plus A transpose is equals to A plus A transpose whole transpose. Hence it is symmetric. This is what we want to prove, that yes, this is symmetric. Similarly, you can show that this is skew symmetric. How will you show? You will first find this and then find this, and you will see that both this and this, they are equal. Okay, fine. Now let's move to the next question. Question number 9. What does question number 9 says? We have to find this and this when our A matrix is this. Okay, this is again a second theorem verification, not verification but a finding. Okay, let's see this. We are given A matrix. Okay, if A matrix is given, then what we have to find? We have to find this and this. It can very easily be done. We can simply find A inverse first, and then accordingly we can add this A with this A inverse. Let me show you. Let me show one part of it. I will find this for you. Okay, let me make some space. Okay, so it is question number 9. Our A matrix is 0 A B minus A 0 0 C minus C and minus B here. Okay, if I find A transpose, my matrix will become 0 A B minus A 0 C, you can see from here, and minus B minus C 0. This is my A transpose. Now I have to find A plus A transpose. What will be A plus A transpose then? 0 here. Okay, 0 here. It is also 0. So if you examine that, all the entries are actually 0, right? And if I take half of it basically multiplication of this each and every entry with half, I get the same matrix. Okay, now I have to show what I have to not. Okay, sorry, the showing part is in the next question. I have to just find it. So I have find it that this is nothing but a zero matrix, and you can see actually about which I was talking a few moments earlier, that we can show that this is a symmetric matrix, right? If I transpose it, I will again get a zero matrix like this, and both the transpose and the original matrix are same, so I get a symmetric matrix. And this is what the theorem says, that such type of matrix will be symmetric matrix. Similarly, you can also find this, and if you examine, then you will reach to a conclusion that it would be a skew symmetric matrix, right? Okay, so let's end the lecture today up to here, and we will discuss the remaining questions in the next lecture. Till then, keep studying and try to attempt the parts which I have left for you. In case you have any doubt, you can write it in the comment section. Also, you can connect with us via various social media handles. Thank you.